In this video, we are going to look at speed of light, and this is the first video on the topic of relativity. Now, we all know that the speed of light is denoted by c, and it is 3 times 10 to the power 8 meter per second. Now, this is a speed in vacuum, and it is a constant. And what is most weird or surprising in this thing is that speed of light is always constant. You cannot change the speed of light. Let's look at a few examples. So let's look at a classical mechanics example. Suppose you're on a trolley and you're going with a speed of 50 meters per second, and you are sitting here and you throw a ball with 25 meters per second. Let me explain this situation again. This trolley is moving with a speed of 50 meters per second, and you're sitting on this trolley. And when you throw this ball in your hand, you are able to throw that with a speed of 25 meters per second. So if you got a stationary observer here watching from here, what would be the speed of this ball as per this observer? What will be the speed measured by this observer here of the speed of this ball? Now all of us know that because the trolley is traveling with 50 meters per second, and this ball would be traveling with respect to this person with 25 meters per second, and this person is already traveling with 50 meters per second. So the speed observed by this man will be 75 meters per second. But if you consider this similar example, suppose we have a railway carriage which is moving with substantial speed of light, right? So let's say suppose it's moving with the speed of 0.5 c, which is half the speed of light. It's moving in this direction. It is moving in this direction, and now at a certain instant I turn on a light here, a searchlight here, and this searchlight basically is producing a beam of light, and that beam of light is traveling with the speed of c with respect to this trolley. By comparing with the previous example here, by comparing with this example here, some of us might be tempted to say the speed of light measured by this person here, this person B here, would be c plus 0.5 c, which is equals to 1.5 c. Just similar to this example here, but this is the weird characteristic of light, that this person will see the speed of light as only c, not as 1.5 c. If you have one person sitting here observing here, and this person measures the speed of light, that person will also see the speed of light as c. So it's the same light here, and being observed by two persons, one person here and one person here, person A and person B. In both the cases, the speed of light would come out to be c. We cannot change the speed of light. That is a weird fact about the light, and it gives rise to many complications. I'll repeat this thing again, that speed of light is always c, no matter what's the speed of the observer. I think write that. The speed of light in vacuum is always c, irrespective of the speed of the observer. It gives rise to many different results, and one we are going to look at is simultaneity, the concept of simultaneity. What it says is, because the speed of light is always c, it means that two events which are simultaneous in one frame of reference may not be simultaneous in other frame of reference. And here we look at the classical thought experiment that Einstein thought about. So suppose we have this railway carriage here, and in railway carriage you got one person sitting here, one person sitting here in the middle. Let me clear that, it didn't come out really well. So we got one person sitting here in the middle, and we got one observer here which is outside. So there are two frame of reference. One frame of reference is this railway carriage which is traveling with a speed of u, and the second frame of reference, this is the frame of reference of this person which is stationary. Now suppose the lightning strikes at these 2 points which we can call A and B, and it strikes simultaneously, and C and D here. Now lightning strikes at all these 4 points simultaneously. Now when we look at this person here, let me again repeat, this lightning is striking C and D which are on the ground, and here A and B are on the carriage. So lightning is striking at these places. So when this person looks at the striking of light at A and B, we'll see that this distance and that distance is same as this distance and that distance. So this person, let's call it this person B, this person A. The B will be able to see these two lightnings at the same time, because these 2 points C and D are equidistant from B. Oh, okay, let's give them separate names. So I think P and Q, not A and B. So this person Q here, he sees these C and D simultaneously, because when lightning strikes these 2 points, light travels from these 2 points and reach Q at the same time. So Q will take these two events to be simultaneous. Same is the case with the A and B. So we can say that for Q, A and B are simultaneous. But let's look at this person now. Just keep in mind that this railway carriage is traveling with a speed of v towards the right. When the lightning strikes these 2 points A and B, lightning starts traveling towards this person P, but this person is moving towards the right. This person is moving towards the right, so the light which is starting from B will reach person P sooner than the light which is starting from A. In other words, because person P is moving towards the event, person P will see that event sooner, or the person P will come across this event sooner than it would come across the event happening at A. Right? It's similar to the case when two persons are talking and you are in the middle and you start walking towards one person. If you start moving towards one person, then this sound light created by this person will be heard sooner by this person, because this person is moving towards the source of the sound. The same is the case here. The same is the case here, and this person P is moving towards the event, so the light from B would reach P sooner than the light from A, and therefore for the person P, the two events will not happen at the same time. Person P will think that B has happened earlier and A happened later. So we can say that for P, A and B are not simultaneous. In general, we can say that the event towards which an observer is moving will be observed sooner.